Welcome to Your Math Explained, where we make math simple and clear. My name is Angela. In this video, we will tackle two contest-level problems involving exponential equations. The focus of this video is to learn how to logically develop the next steps to work through the problems. Make sure you have a strong understanding of exponential and log laws, because we will be depending on them heavily here. Our first question here is from the 2011 Euclid contest. So the trick to a lot of these contest problems is pattern recognition. And in this particular problem, what you're going to notice is that the term 2 to the power of log x appears multiple times in some sort of variation. The only difference is on the left-hand side, we have a squared on top of the x. And then on the right-hand side, we have this extra plus 1. But by now, you're probably familiar enough with exponent and log laws to know that we have ways of dealing with that. So we're going to use those laws to manipulate these two expressions so that we end up with the term 2 to the power of log x. So the left-hand side, the power rule tells us that we can rewrite that as 2 to the power of, and we can pull the 2 to the front, and that'll be 2 times log x. And then on the right-hand side, we have 3 times. And since we have 1 plus log x as the exponent, we can actually divide that up into two exponents. So this will be 2 to the power of 1 times 2 to the power of log x. And in fact, we can actually rewrite the left-hand side as 2 to the power of log x all to the power of 2. And then the right-hand side, let's go ahead and simplify that a little bit. So this is going to be 6 times 2 to the power of log x plus 16. And now we're going to go ahead and do a substitution. So we're going to let u be equal to 2 to the power of log x. So that means we're going to rewrite our equation in terms of u. And this is going to be equal to u squared is equal to 6 times u plus 16. And now this is just a quadratic equation that we have to solve. So let's move everything to one side. We get u squared minus 6u minus 16 is equal to 0. And we can solve this by factoring. And that's going to give us u minus 8 times u plus 2 is equal to 0. So that gives us two possible solutions. The first one is u is equal to 8, and the second one is u is equal to negative 2. So now substituting 2 to the power of log x back into u, we get 2 to the power of log x is equal to 8, or 2 to the power of log x is equal to negative 2. But exponential equations cannot equal something negative. So that means we're not going to have any solutions for the right equation. And then for the left one, we get log x is equal to 3. So therefore, we get x is equal to 10 to the power of 3, which is 1,000. Now for the next problem, we're given two equations and we're asked to find the value of x minus y. So looking at these two equations here, the second one has a base of 2, but the first one has a base of 4. However, we know that we can rewrite the first one in terms of base 2 as well. So if we rewrite the first one, 4 to the power of x can be written as 2 to the power of 2x. And 4 to the power of y can be written as 2 to the power of 2y. And this is equal to 24. And again, we're just going to reorganize that a little bit because that can be rewritten as 2 to the x all squared minus 2 to the y all squared is equal to 24. And then as for the second equation, we can use our exponent law to divide that up into two exponents. So this would be 2 to the power of x times 2 to the power of y is equal to 35. And then we can go ahead and isolate one of them. So let's say we isolate 2 to the power of x. Then we get 2 to the power of x is equal to 35 over 2 to the power of y. So what we're going to do is we're going to substitute the expression for 2 to the power of x into the first equation. So that means we get 35 over 2 to the power of y all squared minus 2 to the power of y all squared is equal to 24. And just like the previous question, we're going to do a substitution here so that things look a little bit simpler. And the substitution that we're going to do is we're going to let u be equal to 2 to the power of y. So then that means this is going to be 35 over u all squared minus u squared is equal to 24. Next, we're going to multiply this entire equation by u squared, just so that we can get rid of the denominator. So then this ends up being 35 squared minus u to the power of 4 minus 24u squared is equal to 0. And really, this is just a hidden quadratics equation. So again, we can factor this. And once we factor that, we're going to get this is equal to u squared plus 49 times u squared minus 25 is equal to 0, which means we get u squared is equal to negative 49 or u squared is equal to 25. But we know that the square of a number can never equal to a negative number, so we have no solutions here. And then for the second one, we get u is equal to plus or minus 5. But remember that we did a substitution before, so now we have to substitute that back. And u is equal to 2 to the power of y. So that means we get 2 to the power of y is equal to 5, or 2 to the power of y is equal to negative 5. But 2 to the power of y can never be a negative number, so we can go ahead and toss out this equation as well. So finally, we get our one solution, which is y is equal to log base 2 of 5. So going back up to our second equation, we can actually go ahead and solve for x now. So using the equation in the box here, we have 2 to the power of x is equal to 35 over 2 to the power of y. And since y is equal to log base 2 of 5, this is 2 to the power of log base 2 of 5. So this means 2 to the power of x is equal to 35 over 5, which is equal to 7. So then we get x is equal to log base 2 of 7. And now we can finally go ahead and put these two together because the original question is asking us to find the value of x minus y. So therefore, x minus y is equal to log base 2 of 7 minus log base 2 of 5. And then using our log laws, we can combine these two logs into 1. So therefore, x minus y is equal to log base 2 of 7 over 5. So a quick recap of everything we covered in this video. In both problems, we used a substitution to simplify our tricky-looking exponentials to reduce the problem into something that we're more comfortable with. And contest problems love to disguise the structure, but with practice, you'll start to recognize when it's time to make that substitution. So now it is your turn to give this a try. Can you solve for x and y if 9 to the power of x plus 9 to the power of y is 194 and 3 to the power of x plus y is equal to 81? Make sure to leave your answer in the comments below and let us know if you'd like to see more contest problems in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.